So just before starting, sir, Kshitij from our science club would like to give a brief introduction.
All right, sure.
Kshitij, you can give the introduction.
Yes, thank you. Good afternoon to everyone present here. I'm Kshitij Kodalikar. Allow me to brief you about Mr. Rajgopal Patil. Mr. Rajgopal Patil has been conducting research in the field of bioacoustics since 2010. He has published research papers in several respected journals. During his career, after traveling to many different places, he has managed to record more than 5,000 calls by birds and other animals. He is a member of Institute of Natural History Education and Research Pune, an organization that conducts research in the field of natural history and biodiversity conservation, and also holds courses on various topics such as herpetology, arthropods, ornithology, for which he also conducts lectures. Rajgopal sir is also an experienced technology executive with extensive international experience in IT consulting, professional services management, and enterprise resource planning at Fortune 500 companies. Without any further ado, I request Mr. Rajgopal sir to begin with his intriguing talk on bioacoustics.
Thank you so much, Kshitij. Thanks for inviting me and allowing me to share my passion and interest in these sounds of nature. Let me see if let me just get my screen shared here. You guys see it?
Not yet, sir. Yes, sir. Now we can go.
Okay. I hope. Do you see the whole thing, or hold on, just a minute. Okay, how about now? Is this better?
Yes, sir.
Yes, sir.
Okay, okay, all right, great. So let me, this is actually a pretty vast topic, and I think it's quite challenging to do it over internet, but I'm going to try. So, see, this topic has got to do more with sounds than sights, at what these internet allows right now. And what is happening is, when I've tried in previous versions, I've seen that the sounds are not exactly audible the way I want it. A lot of it gets compressed over these video conferencing softwares or apps that we are all using now, and the sounds don't come out the way it is intended. But what I'm going to try and do here is give you a whole flair of this field by using a few stories. Okay, the way it all started for me is quite long ago. See, I was probably about the age that you guys are right now when I got interested in the natural world around me. I grew up in Mumbai, and obviously, nature is not very easily accessible. But when I got hooked onto it, it was pretty magnetic. Watching birds, butterflies, and flowers, and all other animals, it was pretty exciting. Luckily, we had this Borivali National Park right at our doorsteps, and which was our quite frequent haunt at that time. And we could go around. There were not too many restrictions, for better or worse. But the thing is, we could go to a lot of places inside, and it was an amazing place. Outside you had a very noisy world, a city bustling with people, and once you're inside, you have so many things. Most of the focus at that time was obviously, as we started this field, is identify as many creatures as you can. Identify those birds and those butterflies. We had obviously we have much better guides today than we had at that time. But more than that, what captured the imagination was the enormous difference between the city and the natural places, like these national parks. And as I continued watching birds in my life, as Kshitish just mentioned, I realized that there is a lot more that nature is offering beyond identifying the various species that are available. It gets a lot more exciting the moment we go beyond that. And then I started recording sounds about 10, 11 years ago. And see, the thing is, the sounds of birds was always there. And there were few people in BNHS and WWF at that time who were pretty good at identifying birds by their calls. And it was just amazing for me. They could see birds before you could see them. That was the way. And they could hear something and they'll say there is this Jordan's chloropsis, or leaf bird as we call now, that's singing over there. There's some other bird, over on the other side of the tree. And it was an amazing way to, and that is what got me looking into these bird calls to start with. So I started recording, as I said, and then more I recorded, I started recording birds. I did some amphibia, especially frogs, and few other animals. And more I recorded, more I became aware of the tremendous silence that this natural world offered us. See, at that time, mountain pass, as you go hike up the Sahyadri mountains, uh, or you go in Himalayas. I was lucky to have friends, who understood the importance of those moments. You go and sit in those beautiful places, and it's wonderful if you can spend some time in absolute silence. You know, and those are the ones, in those amazing landscapes, it captures that moment like nothing else. I've enjoyed photographing nature quite a bit. But see, after taking a lot of photos and videos, I felt nothing recreates the feel of place like a sound recording. Uh, every time I hear my recordings back again, it has this amazing ability to take me back to that same place. And and nothing else, even videos somehow, for whatever reason, falls a little bit short of creating that feeling. So I realized that sound is kind of the essence of the experience of our natural world. So it is a challenge to introduce this topic, but what I'm going to try and do today is I'm going to give you a couple of stories that of very interesting people, and that will kind of get you a feel of this whole field. The first one I'm going to talk about today is a guy named Bernie Krause. Now, Bernie Krause, this guy here, he was a guitarist in a band called Weavers, and then a sound artist in Hollywood. But the thing is, he has been recording natural world for more than 50 years now. He records natural soundscapes, and he has accumulated thousands of hours of recording. In fact, these soundscapes brought out a very interesting phenomena which otherwise, would have gone unnoticed. I'm sure you probably have heard, I don't know how many of you have heard this word, soundscape. What does a soundscape mean? We all have heard of landscape, right? But not many of us know a soundscape. It was a guy named R. Murray Schafer, who himself was a naturalist. He was a composer as well as a philosopher. He has written a few books. He used this term back in 1970s. He recognized that sounds are ecological properties of landscapes. Referring to soundscapes as the acoustical characteristics of an area that reflects natural processes. See the amazing words that he used, ecological properties. I don't think we ever think of sounds or natural sounds in that way. See, when out there in nature, all kinds of things create a sound signature. From tiny ants to insects, from insect larvae breeding inside a tree to large cetacean animals, sea animals like whales. They are all creating fantastic sounds. Not just that, every habitat on Earth creates a sound signature. From forests of our Sayadri to the coral reefs of Great Barrier, they produce a vibrant animal orchestra. Every soundscape that springs from a wild habitat generates its own unique signature, a signature that contains an incredible amount of information. The signature of properties of habitat, it's the habitat that deeply affects the soundscape. See, in a hilly landscape or in a hilly habitat, the sound tends to be more contained. Okay? So, in a place like this, there are a lot of things that sound can bounce back from. When it doesn't travel a whole lot, there is not a whole lot of place for sound to travel in a place like this. So the kind of sound that this kind of landscape creates is quite different compared to an open grassland. In an open grassland, the sound disperses a lot more quickly and it seems to get lost. See, the acoustics of a single location can vary greatly over the course of each season also. Depending on the density and the type of dominant vegetations, for example, broadleaves, we have a lot of broadleaves forests, deciduous, moist deciduous, and evergreen forest. These leaves absorb a lot of sounds compared to a conifer forest, where leaves are more needle-like, and they don't contribute a whole lot in absorbing those sounds. The geography of the area also affects the sound. A rocky, hilly, mountainous place compared to a flat lake, or open areas. Each of these kind of geography is also affecting the kind of the way sound reflects off over, let's say, a saturated, or these are very leaves that are there in these forests. They also are quite unique, and they also play a big role in the soundscape of the place. The ground that is wet with rain will bounce off a lot more sounds compared to an open, drier kind of a ground. If you go, for example, in a forest when it's dry, you'll see the sounds are a lot more hushed. It's a lot more quieter, and those places that sound also does not travel, or as far as it normally can. Let me give you a example of this, the way these soundscapes play out. Coming back to Bernie Krause's story that I was talking about, he records soundscapes, basically records whatever is out there, is creating sound. He records it, and he records this soundscape in various places, and then he revisits some of those locations again over time, and he captures what is changing, captures the changes to that soundscape, as I said, in different season, different places over the time. So there is this place called as the Lincoln Meadows that you're seeing a picture of. This Lincoln Meadows is in California, and this place, he has been capturing sounds like for over 25 years. And what happened is here was quite interesting. So in this place, back in around in 80s, late 80s, California company, logging companies wanted to use this place for logging. But there was a lot of resistance from the residents who said, you are going to destroy this whole place, so we can't allow logging. Obviously that logging was going to bring some revenue to those locals, and so there was kind of a little bit of conflict. This logging company came out with a very interesting idea to sell that whole concept is what they said is that we are not going to log the whole forest. We are not going to take off the chunks of it. What we will do is called as a selective logging. Now, what selective logging means is that they are going to take a few trees, so they will leave a few trees, take one, leave a few trees, take one. So by picking up those places, what they promise is that the residents would never even see much of an impact. That removal of trees will be so far spread out that it will have no impact either on the way it looks or on the um, wildlife which is residing there. And that is how they sold it. But at that point, Bernie Krause came in and he asked for a permission to record the sounds of that habitat before and after logging. So he recorded rich dawn chorus in Lincoln Meadows. Okay, what I'm showing you is a spectrograph or a sonogram. This is a way you can take your recordings and create a visualization of it. For some of you whom you are not familiar with this, can look very gibberish right now. But I'll give you a quick background on this. What we have on the x-axis is the time, but on the y-axis is where that sound is converted into its individual frequencies. So you will see there are some of these bright lines which are going up and down. These are vaguely lines across from top to bottom. You'll see these are actually the sounds of various birds and insects which are giving a call. And if you look at, I don't know if you can see my mouse here. Can you guys see my mouse?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great, wonderful. So if you see there is some bird which is creating a periodic whistle. It's like a kind of a trail going over here. Then there is some kind of warbling, a high-pitch warbling which is going on here. Then there are some very loud birds. See, the brighter these lines are, the louder. There is a lot more energy into that sound. So there are some very loud birds which are singing over here. So there are a lot of these birds which are occupying different places in this whole soundscape of this place. You can see that it is a pretty rich, pretty vibrant kind of place. So there are probably sparrows, there are warblers here, there are woodpeckers, not in this particular spectrograph, but you can see the sounds of the woodpecker makes. Woodpeckers have a very interesting way of singing. They, compared to other birds, they have this whole musical instrument called the tree bark, on which they hit their heads and create their own music. So they do. Then there are probably robins and a lot of other birds which are in this whole Lincoln Meadows place that you can see. But see, a year later, nothing. People who visited that place, they said, "Oh, wonderful! Nothing has changed. It looks as it was before. So there are no stumps, there are no debris. It's just still lush conifer, and there is nice understory." But to the ear, to the sound, the whole place had changed quite a bit. Now you can see how quiet it had gone. Same time, same place, but you can see the change is pretty drastic here. So you can see that basically there is hardly any birds here. It's pretty much lot of quiet. There is some sound here, and I'll come to that a little later, but this is not animal sound. Okay, so there are a lot of other sounds that are taking. Just one bit of probably this is a woodpecker here that we are seeing in this region. But apart from that, it's largely very, very quiet. So you could see, although it wasn't visible to our eyes, but the sound here, the soundscape here, could tell a story which a photograph wouldn't be able to do. He says that diversity hasn't even returned years later. So that selective logging, though it doesn't look much destructive, but it can be pretty highly impactful on the bird life and the animal life in that place. See, he has this very interesting saying, in his book. He says, "Our ears don't lie. While a picture may be worth 1,000 words, a soundscape is worth 1,000 pictures." it's an amazing story, how the sound recordings can reveal something which wasn't obvious. So this is another, what I want to say is it's an excellent tool that is available for ecologists as well as naturalists. You can use this tool to evaluate the health of a habitat across the whole spectrum, of life. So it's not just birds, every other creature that creates a sound will have its place in a soundscape. So let's understand this soundscape a little bit better. I wanted to show you as you're looking at this graph here, you can see there are a lot of other things that create sound. So there are three main components to a soundscape. The first one is the geophony. Now, geophony is the sound made by all the non-biological sources. Okay, if you take a habitat, there will be wind in the trees or the water in the stream, waves at the ocean shore, raindrops, movements of the earth. So geophony is the name for natural sounds that are arising from non-biological. So there are some few subcategories here. But then before you look, this is the first sounds of Earth, even before any life came on. So these are the first few sounds. So now every acoustically sensitive organism, by which means is that every organism that uses sound, either to communicate or to sense the environment around it, it has to accommodate for this geophony. So each animal has to establish its own bandwidth in which it can click, it can hiss, it can croak, it can sing. It has to pick its own specific bandwidth while taking care or in relation to the sound that these non-biological earth makes. So this is a key for it. And so what does this, what is happening here is, it's very likely that the water would be the first natural sound heard by any organisms that could perceive sound. See, all organisms, as you all know, have always been dependent on water for life. And water is the main element in creation of the terrestrial orchestra, the orchestra of the earth. The abundance of living sounds in the streams, ponds, swamps, lakes, reefs, and oceans of the world is just extraordinary. The subtleties of seashore, the seashore is an amazing acoustic place. The subtleties of the seashore sounds, around the world is remarkable. As you start listening to this, as you get better at listening to this, you can understand this. The water creates a very different sounds at each beach. So each beach has its own acoustic signature, and it's a result of many things: the waves, the rakes that are hitting, then the depth of the water offshore, as well as the kind of shoreline it has, the currents, the rocks that form the shorelines, whether it is sand or whether it is a rocky shore, the temperature of the water, even the surrounding terrestrial environment also can impact the way a beach sounds. So if you see the breaking waves, if you go to places like Murud or Gokarn or any of these beautiful beaches that we have, or even other rocky beaches, you can see that sound is quite different from one place to another. In comparison, if you take the freshwater lakes, no matter how big, the shore waves that they create tend to be obviously much smaller in size, but they're also higher in pitch. That is the way you see the sounds of seashore is much lower in the pitch. By pitch, I mean the frequency of the sound. So one of the key components or properties of sound that we look at is obviously the pitch. Where in that whole pitch, if you remember that graph a few slides ago, so a higher pitched animal would be much higher on the y-axis, and these will be very high pitched birds like we have these vernal hanging parrots around us, sunbirds. A lot of these canopy birds tend to have very high pitched sounds. Or if you go to open grasslands or larks and all, they tend to have a little on a higher side, not as high as these sunbirds or vernal hanging parrots and those kind of things, but somewhere a little lower, but still on the higher side. So when we look at this pitch, then there are other things that create a much lower kind of sound, like probably you would hear a cockle that we have much lower. Owls typically, some of the owls have much low kind of sound. Or another example of a low pitch would be even our doves, which create sounds on a much lower side of the whole scale. So that's frequency is one of the key properties. There are quite a few. Sound is not a very monotonous thing. There are a lot of things that affect the sound. But pitch is one of the key ones. Then there is the intensity of the sound, then there is a sound level, the pressure level that varies depending on the way the sound is generated. So there are quite a few of these things that we need to consider. These are the few basic things. Apart from that, then there is as I mentioned, the surroundings, the way your sound reflects off of various things. That has to be taken into account by all these creatures that live in a habitat, or the way the sound is absorbed or distorted by things like wind. All that come into play, and you will see that evolution has, over the years, taken care of a lot of these nuances, and we can actually, when you hear a sound or listen to it carefully and you dig a little bit in bioacoustics, you will realize where that sound is probably coming from, what kind of animal it is. It tells you a lot about its not only its habitat, but also the size probably it's using, what kind of vocal apparatus it has to be able to create certain sounds, and we can figure out to a certain extent what kind of energy is being spent. So sound can tell us a lot of things. So when we look at a freshwater lake like this, again, the sounds created are of a higher pitch. See, another factor is that the fresh water is also much less dense than the salt water, and that also affects the kind of sound that the water creates. These aren't the only examples of water. The stream, the rain, even glaciers can create unique sounds. Each glacier moves at its own pace. Some of the glacier near polar regions, they empty out in ocean, like the one we are seeing here on the screen. This is a picture from a glacier in Alaska. So the leading edge of the glacier continually keeps releasing huge masses of ice, quite a few 100 feet in height, and they crash thunderously into the sea below. Thunder reminds me, the thunder is another one, which is another presence, example of sound that Earth creates. It's an example of geophony. So, and finally, the wind. Wind also is another great contributor to the sounds of geophony. So, geophony, as you can see, is this whole maze of complex sounds that Earth can create. It's a huge challenge. If you're trying to record this geophony, it's a big challenge. We hear these very well. Our ears are an amazing instruments. When it comes to microphones, we are still struggling quite a bit in order to be able to capture what our ears can effortlessly capture. So I'm not going to go a whole lot into the instruments today, but it takes a different kind of instruments depending on what you're trying to capture here. Geophony is one of the most complex kind of a thing, because of the huge range of sound pressures that we see, or different kind of amazing amount of frequencies that we see in these sounds. We have our own limitations, of course. Typically human ears also have a limitation. We hear some amount of low frequencies quite well, partly because a lot of our own voices are in lower frequencies. Typically men tend to have much lower, on an average, much lower frequencies compared to women, but which will probably be, we are still talking about few hundred hertz. But when you look at these sounds in nature, they can go pretty high. Our ears can, best at your age, definitely you can pretty comfortably hear something around between 15 to 20,000 hertz. But as we age, our hearing also, the kind of frequencies that we can hear also comes down. So as we age, you tend to lose the ability to hear these higher frequency sounds. But when it comes to microphone, again, I was saying it's a huge challenge to record these. Some of these sounds we can record pretty very nicely, and that is where different kind of microphones can have a different impact on the way you record them. The next one is the biophony. This is something we are all very well quite aware of. So biophony is, as you probably have guessed, is the sound generated by the organisms, a variety of organisms in different habitats. So that is basically from a smallest of insects to a very large whales. Whales can create sounds that can travel 500 miles, something around 700-800 kilometers before it dies out. So a small insect or something which is living in a tree bark or even spiders that create sounds, they're creating sounds for a very small distance around them, while the whales are creating for a very large distance. Similarly, we are seeing a lot of these elephants create sounds in a very infrasonic range, which is below our human hearing, that can travel a long distance. So this, when it comes to biological sounds, geophony is the base, and based on that, the evolution has created a variety, a diversity of these calls and croaks and roars and everything, which builds on top of that. And it's, as you listen to it, you can see a beautiful synchrony in all of this. So they are very nicely built. You'll see a bird which sings in particular frequency, the other birds will pick some other frequency. There is one which uses a certain pattern, the other will use a different pattern to distinguish itself. So every creature, every organism is trying to find its place. Just the way you find an ecological niche, they're finding an acoustical niche. And this niche is how it's critical for their living. And I'll come talk about that briefly towards the end. We talked about whales and amazing kind of sounds that they can generate. This has been an amazing place where there is a lot of things are being studied and a lot of research is being done. I think recently it has begun even in India. There is a researcher, I am not able to remember her name, but she has done over the last year or so, she has recorded blue whales in our own waters in the and that's an amazing first for us. And I am hoping that there is going to be a lot more of those, because in this bioacoustics, there has been a tremendous amount of research that has conducted abroad. Not a whole lot in India yet. I'm hoping that over the next few years, all of this should change quite a bit, and we should see more people, figuring out our own sounds. We are getting some research from abroad, but I'm hoping that there is still a lot we need to know about our own natural world, and it is critical. But the thing most important, unfortunately, is the third one, which is the anthrophony. Anthrophony, by itself, this is, as many of you probably have guessed, this is the sound created by humans. So unlike, there is one part of anthrophony, which is our human voices or our music, which are very nice and coherent parts that we create. We have myriad of languages, and you can see that many times that blends quite nicely. But unfortunately, the most other sounds that we create, they're chaotic or they are incoherent. It is pretty much very nicely defined in one word: noise, right? It's quite disturbing. This is not picking up niche, or it is not working with the surrounding sounds. This, with our increasing industrial age, the sounds of machines, these vehicles, loudspeakers, we are enormously adding to the destructive noise, and this noise obviously is very harmful to a lot of organisms in nature. And we'll talk a little bit also about that if we get some time. But I want to turn to another example, picking up on this thing, is about these toads. There's a toad called Great Basin's spadefoot. This is in California, and it has a pretty a range over there in that space. And what we're looking at, this is the lake called as the Mono Lake. This is its main habitat. See, this toad, it digs itself down about a meter, under this. Although we are seeing a lake, but most of the surrounding area is desert here. So it digs itself in the desert soil. And if it doesn't rain, as it doesn't, basically California has this long mountain range along the coast, which prevents a whole lot of moisture crossing over. And then it has created this huge land of very dry habitat. And there are very unique species that live in this dry habitat, like this, the spadefoot that we're talking about. And this has an amazing ability. Once it digs in there, if the conditions are not right, if it doesn't rain, it can remain there for many seasons. But when the conditions are right, these emerge again. All these toads emerge again. And so when there is enough moisture in the spring, these frogs will come out, they'll dig themselves to the surface, and they gather around these large, very vernal pools in huge numbers. And they vocalize in a chorus. And this chorus is absolutely important for them. Now you will realize this chorus is nothing but a breeding call, and that is what is very essential for them to pair up and create a new generation for their procreation. This is a very essential part for them, and that chorus has a very key use. So there are basically two big reasons why they do this. The first is a competitive, because they are looking for mates, and the second is cooperative. They are all vocalizing in sync together. And what that does, apart from out performing each other, these males, that some kind of synchronization there creates a very challenging environment for their numerous predators. Those predators makes it very difficult for them to localize an individual because of this chorus. So they have a lot of these coyotes and foxes and owls and all that they have to fend off before they can even find a partner. So now this lake is also, apart from these toads, it's also a favorite habitat, not really habitat, but a place for US Navy jets. So they use this vast empty area for their fighters. And what they do here is they fly these, enormous speed, more than 1,000 kilometers per hour, and at a very low altitude, just only about a couple hundred meters above the ground level over this Mono Basin. It can be thrilling to watch, but what it is happening is that these are so loud. These planes are so loud. You can hear these ponds can be pretty far off, few kilometers away from where these planes are flying, but that noise can mask these whole chorusing toads. So that as soon as these fly, then they can go on for a while. So that noise, it breaks the chorus of these toads. Now at the end of that flyby, they saw that when the research they did, they saw that the frogs take nearly 45 minutes back again to regain their chorusing. So what is happening here is that, in a place like this, that break creates a nice entry for a lot of these predators now. So these predators use that break, coyotes and owls and all, they'll pick off a lot of these toads pretty easily. So you see, you can pretty easily see the kind of challenges we are seeing and happening in this anthropony that is creating for the natural world. So this is a very interesting way that Bonnie Krause puts it here, is that he says what this kind of anthropony is doing is it's spreading a great silence over the natural world. Even as the sounds of man is becoming deafening. So you can see in just one sentence, how the whole soundscape is shifting from one, from a biophony over into the anthrophony. You should read his book. It's called as A Great Animal Orchestra. It's wonderful. He says that little by little, the vast orchestra of life, the chorus of the natural world, is in the process of being quietened. I want to give another example, another story of this guy called Gordon Hempton. I want to use these two guys as an example of what is happening in the bioacoustic world. The whole talk of noise brings me to talking about Gordon. He is a Emmy-winning sound artist, but he is also a person, a very interesting person. He has shown a very inspiring way to fight noise. See, in his youth he was a plant pathologist. So he was traveling for his university work, and on a long drive, he says he slept in a cornfield patch, and there he experienced crickets and rolling thunder in the background as he slept in that patch. That was just captivating. He realized that he had never heard the earth before. See, Gordon Hempton is passionate about silence. He says it is our birthright to listen quietly and undisturbed, and listen to the natural environment and take whatever meaning that we want. So as we saw earlier, before noises of mankind, there were only the sounds of natural world. And our ears have evolved perfectly tuned to hear these sounds. The sounds of wind that foretell a change in weather, the sounds of bird that indicate a safe place for us, a call of a bird like pied-crested cuckoo that heralds the onset of monsoon, which would replenish our earth. The sounds of shifting tides remind us of continuous play in the rhythm of the earth. So all these sounds, they connect us to our land, they connect us to the natural world, and they connect us to our past. So it is here that we are reminded of things that are important to us. So this world is filled with sounds of earth, and all natural organisms is the silence that we seek. So the silence is, as you see, is not an absence of something, but it is the presence of everything. This silence has a huge importance for us. See, in India, even I've read in some of these yogic literature where they talk a lot about the importance of silence. There is one nice line. It says, if you sit with an increasing stillness and attune our mind to the sky or to the ocean or to the myriad stars at night, all these indicators are of vastness. So as we listen to this vastness, or as we tune ourselves to that silence, our mind gradually stills and the heart is filled with quiet joy. So listening to natural sounds is an opportunity not only to heal, but also to discover something incredible. See, it's a wonderful way to discover all these in our own life. So as we live in cities, our auditory horizon is quite small. Only a couple of, probably we'll go a few buildings here and few buildings there. That is all the distance that you hear. You don't hear much beyond that. So if you are lucky, you will probably hear the footsteps of people around you. So it's the same information, really. So, when you're listening around, how many species do you think you're hearing in a city setting? It's only those same few species that we hear. So now imagine listening to the magnificent wild and open spaces. When we listen and truly listen, so you're not trying to hear what you want to hear, but you are just being there. You're part of the whole thing. listening is taking all sounds with equal value. So when you listen to a place which is naturally silent place, and you hear nature at its most natural, it is no longer merely sound. It is in my opinion, it's a beautiful music. So you see, when the man-made noise intrudes in the wilderness, it is like that static that we hear. When you're talking to somebody on a cell phone, you hear this lot of static every now and then. It is that kind of thing. You are not able to get the signal, this voice of other person, or in this case, the voice of the nature. So not just us, it also impairs the ability of animals to communicate. So the wildlife is obviously as busy as we are in communicating, and this is very crucial for their survival. So what I'm going to, the way I was mentioning, the reason I was mentioning Gordon is that he has this amazing, brilliant idea. He wanted to see, when he saw that there are hardly few places which are remaining where the human sounds have not intruded, said, this is what I am going to go and find out. So he said that I'm going to find those spots of absolute silence, where you only hear the natural sounds. You don't hear sounds that humans have created. So he said that I want to find a place where you can get at least 15 minutes. If you go to that place, you get at least 15 minutes without any kind of man-made noise. So he started looking for these places in US, and he hardly found a few. Probably around 20 or so is what he found. And now he says over last 20-25 years, he says only a dozen of them are still remaining. Even others are being intruded upon. So he said he decided that instead of leaving it up to somebody else, he would make his own effort and to save at least 1 square inch of silence. So he decided to do this at a place called Olympic National Park. This is the kind of this photograph is from that place, Olympic National Park, which is in the northwestern part of US. So see, on the Earth Day in 2005, he hiked up a Ho Valley. This is the Ho Valley. This is the Ho River, and he went up the river valley to find a place where all human sounds, all human noise dissipated. What he had to do was, he wanted to go to that quiet place. It took him a hike of about 3 miles and about 5 kilometers up this river inside this whole forest before he could find a place that was really and truly quiet. And he said he put a stone down in that place. Okay, and so from that point onwards, he has defended that place. He said that is the place he's going to defend, and he defended that place ever since, from all kind of noise pollutions. See, you'll say, okay, 1 square inch is not that big a deal. The real big deal is if you want to stand in that place and make sure that you don't hear any human sound, that means you have to really make sure that nothing creates sound or noise for at least around 15 or so kilometers around that. Okay, so basically you end up creating if you take that 15 by 15, so 1500 square kilometer of place has to be quiet. So that is what it takes to create 1 square inch of silence. So he has left a beautiful jar at this place, and so people can write notes and see what kind of how do they feel being in that really quiet place. And he continuously works with the management of the park. He has now gathered a wonderful following all across who have supported him, and he even got the national park itself makes sure that there is not a whole lot of noise created in that place, whether it is any kind of wildlife management or anything, or vehicles or nothing. It's beautiful. But he even got the airlines to stop flying over that place. That is the amazing kind of impact he had. So if you go there, there are hardly any planes flying above, and you get really beautiful. Planes have become very ubiquitous, over the last through this period of COVID, we were a bit lucky where we got a lot better, beautiful silence period. But as it picks up again, you will hardly find even a place where you will not hear a plane over it. So even in the deepest of jungles, you will have these planes flying over you and creating that kind of noise over there. So this is a wonderful idea. I just loved it, and I think our natural places also need a similar protection. It would be so wonderful to have these our own places where we ensure that these are places with beautiful natural science. So that's a kind of a thing, as Robert Frost says, it's a road not taken. You take these different road, and that makes all the kind of difference in the world. So these are a couple of beautiful stories that kind of gives you an introduction, I hope, to the acoustics, the bioacoustics. Bioacoustics is a large science altogether, where some of the things that we mentioned, you can, this is a feel of it, and then we can go on from this place. You can go to a lot of different directions. People have used bioacoustics, like what we heard, these two guys here, Gordon Hempton and Bernie Krause, to create a kind of a beautiful conservation movements. Bioacoustics can also play a very different role in the conservation movement. As I showed before, where you can use bioacoustics to see a variety of diversity and record them compared to what we record visually. So it creates another way for us to figure out what all organisms live here. And these are some of the beautiful. It's an excellent tool when we are looking at at many of these nocturnal creatures. Nocturnal creatures are amazing when it comes to bioacoustics. They are a lot more detectable by their sound rather than by their before we even see it. It's nightjars or owls or frogmouths or many of these species. They are a lot better seen by their sound rather physically by sight. So also there is a couple of other two things that I'm going to mention is another area where it impacts quite a bit is in animal behavior. So study of communication is also largely is part of bioacoustics, where you are studying. There have been a lot of study when it comes to, and still there is a huge amount of remaining. Where we are listening to how the variety of animals pick up and get their own sound. It plays a big role even in the taxonomy. So see, a lot of these species have their own unique signature calls, signature songs, especially. Like we were talking about these frogs before. Each frog has its own kind of sound signature, its own call, and that differentiates it from all other frogs and all other species. And it can create whether it is using a different frequencies, different patterns, different rhythm. There are a lot of varieties of aspects that we can look at when we are looking at studying their sound patterns. And many of these definitions or taxonomy papers, they require you to submit study of their sounds, the acoustic study. When we are this is extremely popular, as I was mentioning, in whales and birds, where there has been a lot of amazing studies that have come, and we are coming to know a huge amount of things about the way these animals behave, the way they attract their mates, the way they communicate with their chicks, the way they forage. So there is a lot of that kind of research is going on. Especially there is quite interesting ones on the way they detect and create alarm about predators. So there are numerous studies that we can talk about here, but I'm going to stop here. I hope I give you a brief introduction to this an amazing field. There are a lot of things you can keep on talking about, the various instruments that you use, a lot of technology that is coming in place. We saw a glimpse with these spectrograms. There are some amazing, wonderful things that are coming in where we can analyze these much more interesting way today than we could earlier. A lot of these are available on our laptops and phones, so you can, even many of you, if you get interested in listening to these sounds, you can go out, record them with your mobile phones. Some basic nice recording apps are available, and you can just record sounds around you, and that's a wonderful beginning to the journey. Right? Thank you so much.
Thank you, sir.
Thank you, sir, for the wonderful talk.
It was really interesting to have a picture of the sound without actually hearing anything, any recording. And
Yeah,
so,
it is. Normally I would love to play many of these recording, and see, the thing is, over internet, over this compression, it's very, very challenging to play a lot of these sounds.
yes,
I would hopefully we'll have an opportunity with this. If we hopefully put this COVID behind us pretty soon, I would be happy to play some of these sounds, and no matter how many words I use today, few recordings, you guys will be hooked to listening to those sounds and recordings, many of these.
okay, sir.
Sir, there are some questions in the chat
There are
box.
some questions in the chat box, sir.
Yeah, you're asking about, I saw this question about recording apps. Quite a few. Only thing I would suggest is look for apps that can record without compression. There are some, these are typically, you will see with PCM, they have this PCM recording, or search for wave recording. I think Tascam has a wonderful one on Android. I will probably share with you guys some of these names that you can use on your app. You can download these apps. Many of them are free. The key thing you have to look for is that they can record in an uncompressed way. That is the best way to keep those. See, a lot of this compression is geared towards the human sound. So the compression typically keeps the frequencies around humans. They use variety of algorithms, but typically it ends up keeping the frequencies around humans. But when it comes to natural world, there is a huge amount of variations. And if you want to keep those variations, you typically want to have an unadulterated way of recording them. And the best way is to record them in the wave format. Wave, we all, many of you, I'm sure, have heard about MP3. MP3 is a highly compressed format. So MP3 has to be avoided as much as you can when you're recording natural sounds. Use wave, which is basically keeps it in as it has recorded, and that allows you, if you listen somewhere else, you can. That's a wonderful one. So look for PCM recorders on your Android, or even iPhone has something called as WavePad. Those are a couple of ones I can think of. These are really good apps that you can use. Is there any biological significance of having a certain pitch of voice, like in humans? Oh yeah, this is a great question, Kevin. Every, as I said, just like ecological niche, animal has to have its own acoustic niche. Now, this acoustic niche is evolved over a time. Why it is in a certain way. It's only, you can only look at the evolution and see. Many places, many times, like a lot of these species, they are studying. You can see the base kind of a call or song that species created. For example, a lot of our warblers, these Philoscopus warblers that we get as migratory, when you go up in Himalayas, you can hear them sing. And when you hear them sing, you can see there are a lot of these species they breed around a ring around the region of Tibet. So you can see how it has changed from one species to another. You can actually make out there is a tiny little change from one species to, and they understand their own sounds very well. So each of them have found a pattern. Frequencies to a certain extent also restricted by the anatomy of your sound producing organ. So your larynx or syrinx in case of birds, that has a certain ability that you can create. Typically bigger throats, bigger animals have an ability to create lower frequency sounds, and smaller animals tend to have higher frequency sounds. But then comes a lot of nuances. It is not as straightforward as that it is. So there are a lot of nuances once we start looking into it. And many places it is the way that sexual selection has played a role in terms of having those frequencies. It comes to a little different. Natural selection plays a role when it comes to calls. For example, when you are looking at alarm calls, that is one area where there has been a lot of research, alarm calls of animals, where that animal is giving an alarm call. It's surprising. You want to know why an animal would give an alarm call, because why does it want to announce its presence if it sees a predator or some kind of threat around it? But it has a very big evolutionary impact, in terms of survivability. An animal or species that gives an alarm call has an impact on a group around it, whether it's family group or related group, or even other species that become aware and are all benefited from that alarm call. But you can see how these alarm calls have co-evolved in many different species to become they give a sound in such a way. I didn't go in a lot of depth in terms of how these different kind of sounds play a role in terms of location. The localizing of sound is a very big topic, and it's a challenging task. We have fortunate because we have ears which are a bit wider, on our heads, help a little bit in terms of localizing a sound, but it's not as straightforward as you think it is. So these alarm frequencies have taken a kind of a niche in that acoustic space where it is not easy for predators to locate the bird or animal which is creating that alarm sound. So these frequencies have a big role, and that's a big topic, but I hope I give you a glimpse of it. There is another question before that. Which instrument generally are used to record these different sounds? Basically, it's a combination. The basic funda is pretty straightforward. You need a microphone to pick the sound and convert it into an electrical signal. But microphones are typically create a very low frequency electric signals, and you need some kind of amplifiers which will enhance those sounds. And then you need a recorder. That recorder will take that sound and store it on any memory card or something like that. So typically all of them are memory cards now. A lot of earlier recordings, they are all on tapes, so they'll put it on. So these are the three basic components, and of course you need some headphones to be able to record. Many of these amplifiers are typically built either in the microphone or in the recorder nowadays, but high quality amplifiers are essential to be able to capture the right kind of sound. Yes, what software is used to produce spectrogram? Somebody answered Raven Pro is excellent, and Raven Pro you can get, it's developed by Cornell, and it's wonderful. There are a few other ones, but Raven Pro you can easily get. It's downloadable. It uses Java, which sometimes can create problem, but otherwise it's wonderful. I have really good experience with Raven. Is there any other courses offered by universities in India and short-term courses in this field? I wish this is still early. We don't have a whole lot of. There are few people who are studying. I know Pratap Singh in WII had done a lot of work on bird songs. He recently retired. There is a team in IISER Tirupati that they are also looking at bioacoustics. So in IISER Pune, I'll remember the name of a professor there who has also started some work on bioacoustics. So it is happening, not in the kind of way. The potential is immense, but in a smaller courses wise, there are hardly right now. I don't think we did conducted a few workshops of a couple of days to get in the basics of bioacoustics, where you can understand how it works for different animal groups and start something of your own. But I think we still need really. We have some plan of starting one next year. Come next year, I think there will be one, especially postgraduate level. So I hope that launches, and that will give some good platform for people who want to study and get some good solid work done. And what is the range of biological sounds that we can hear and differentiate? Again, this is wonderful. See, this is again, as it says, that the sound frequencies can go from very low infrasonic, as I was saying, just little above zero, to all the way into where some of these animals like bats, as you know, extremely high pitch, we can't even hear. We are nowhere close. Most humans, they top out at 20,000 hertz, and many of these go beyond 1 lakh, 1 lakh 50,000 hertz. That is the kind of range most of these Microchiroptera, the insect eating bats use. So there is immense amount of range. When it comes to marine animals, then again it's entirely different ball game altogether, because the way the sound works in that medium compared to air, air is we are very familiar with the way sound works in air. Air is lot less denser than water, obviously, and so in a denser medium, sound can travel very far, but it's very challenging. It's not easy to create that sound. It takes a lot of energy. So the attributes that the sound has in water, and different kind of water, as I mentioned, whether it is in sea or in lakes, there are a lot of fish that are known to use some amount of acoustics for their communication. So there's a vast kind of a range, whether when it comes to the way in terms of frequencies, or in terms of their energy levels or amplitude, as we call it, in terms of the coded signals, the way a lot of these animals code their communication is also quite interesting when we look at these species. So there is a lot of specific sounds, as I said, a song that is meant to attract, and is where you can specify with a high degree of certainty that this is the sound, this is the species that is creating this sound. And on the other hand, we have species that mimic a lot of sounds of other. Many of you probably heard this lyrebird film that was going around on WhatsApp or on social media a few years ago, where it mimics this amazing, not only other animals, other birds, but also a lot of sounds that humans are creating. So there is a very interesting play going on when it comes to the way they are getting coded. So that is just one example. There are a lot of varieties of way. There is a lot of this false coding is going on. So there is a lot of deceit, and very interesting things are happening when it comes to when we get deeper into the study of bioacoustics. I think question Madhurika asked, nowadays anthropogenic noise is causing a lot of problems and might overlap with call frequencies of animals. Are animals evolving their call frequencies to deal with this problem? This is an excellent question. This is a big area of research right now. In Netherlands, there is a team led by Professor Hans Slabbekoorn. They do a lot of work on anthropogenic noise. I think there are a couple other universities where in Europe it is happening. In US, I think there are 2 or 3 universities where they are doing a lot of work on anthropogenic noise and its impact on the animal world. We are seeing a huge impact. You see the species diversity is changing. We were doing some of the studies here ourselves and to see how it impacts. So you can see a lot of these anthropogenic noise in city by city is different. So, but there is some pattern there. It's all at a very low frequency. So the animals with lower frequencies are a lot more affected. But we are seeing even in other species where they are birds in an urban area are using a different frequency level in the same species, which is living in a much more natural areas. So these are some basic things, but there is a lot more happening there. Some of them obviously will probably evolve and keep pace with the kind of noise that we are generating, while some others may not be able to. So there is a real danger there when it comes to anthropogenic noise. It's not just the animals, it creates a tremendous impact even on humans. Noise is a huge source. We don't realize anthropogenic noise is a huge source of stress in humans, and stress is becoming a mega disease in modern humans. So have you encountered birds having sound of same frequency, and or does every bird have a unique frequency? Yeah, they use different variety of. There are even many birds, even if they are similar frequencies, where when we start off, we get confused when we hear birds of similar. For example, a lot of these sweet sounding calls like magpie robins or ioras or orioles, leafbirds, they use a similar frequency band, but you can actually, if you have been out there listening to birds over the time, you'll make out the difference. They have a very different patterns. They have their own favorite notes, and that is one of some of the things you have to put in if you're doing a research and you note what kind of notes do they use. A wonderful book I would recommend is by a researcher called Don Kroodsma. You can look up this book. He has a book on the Birdsong. If you want to get a little more academic, there is a book by Catchpole and Slater called Birdsong, and it goes into a lot of these specific things about the way the bird songs are evolved and various aspects of it. Can bioacoustics be used to decipher the language of animals? Can we find meaning of different? Oh, absolutely. We might not get the whole thing. We will never have the. This is one of the interesting aspects when you do animal behavior is we try to understand everything from a human perspective, but not everything. The way they live their lives are not exactly human perspective. We can only do certain studies and then figure out what do they mean by it by looking at its impact on the recipients of that sound. So you see the impact. If a bird calls, what does its rival do? What does its predators do? What does its mate do or potential mates do? How do they respond to different kind of, and based on that, we can figure out to a certain layer and come out with certain meanings. But we have to be careful that we don't attach an anthropogenic view on those meanings. So we can only come to, if you're interested in this kind of, there is a very beautiful thought process or game, and there's a guy called D. Wall. He has written a book specifically on this topic. It says that are we smart enough to know how smart animals are? So many times, as you've seen, especially in Western culture, animals have been labeled as dumb. Oh, that animal, he's dumb as a bird or dumb as something. All these animals. But the thing is, more we understand them, we realize that we don't have that kind of view to be able to understand why animals are communicating in a certain way. But it's just a one beautiful world. There is a lot of work. It's part of the animal behavior topic overall. But that itself is, we are exploring a lot of those things. You can see it's coming out. So we know some basic categories, and there are some attempts to go a little deeper, especially when it comes to many of these marine mammals. We are coming to know a lot more. Obviously, there is a lot more work if you see in terms of primates or something which are closer to us, where it is comparatively easier to understand what is happening with their communication. In humans, males have flatter voices, females have more shrill voices. Is such trend seen in yeah, absolutely, in other animals? A part of it has to do with the size of the animals. In humans, you will tend to see males are bigger in size and females are typically smaller, and that has a limitation in terms of the frequencies that your larynx can generate. Although there are a lot of variations, individual variations that we see, but that tends to be the nature. A lot of other animals where you have similar kind of relationship. Not all animals have the same relationship. If you see a lot of these raptors or a lot of these ground birds, they have an opposite way, where females are typically bigger than males. And so similarly, it impacts on the sound it generates too. And then there is a lot of deception that is happening, where you see these animals are creating sounds that are a lot more lower, because see, that is how they are seen that the pair mate selection is based on the frequency and the quality of the sound that a male generates. So you'll see there are a lot of these amazing, I will go sometimes, you probably talk about that, you see that amazing things in birds that have been discovered, the way they can manipulate the sounds so that, they have a bigger impact on mate selection. Yes, there is a BNHS short course on introduction to ear burning. Absolutely. Basically, that's where they teach you how to identify different birds by listening to their calls. I haven't had an opportunity, but that sounds wonderful. Are the soundscape being used for weather surveillance? Oh, well, that's an interesting part. I haven't, as far as I know, I don't know about this. This will be a very interesting geophony, and using sounds might be a very interesting way. But I'm not sure. That's probably, there are a lot of aspects, and I think they are yet to be explored. Probably this being one, or I'm not aware of it. Okay, I think Balram is sharing the details of bioacoustics. Yes, great. Thanks, Balram. Share my emails. Yeah, absolutely. Yeah, yes, shared it there. Okay, great.
Sir,
All right.
two questions I think were missed. Like just like birds, do insects have different sounds for different purposes, especially social insects?
Sorry, birds are different sounds and insects. Can you repeat that part? I didn't get that.
Oh, sorry, my bad. Just like birds, do insects have different sounds for different purposes, especially social insects?
Well, insect sound is one area where there is not a whole lot of study. There has been a study in terms of crickets, where we have seen that they have very specific kind of patterns. You know, if you like a soundscape of a place, I know there are some places in Southeast Asia where they have done these soundscape studies. They have seen these crickets occupying each has, if you draw the spectrogram, you will see these insects taking up their own place in the entire that soundscape. Like there are some places they have found up to about 60 species of crickets creating their own sound. So that's an amazing area, but I don't think there is a whole lot of literature available on the going into the meanings and variety. Diversity is more studied in little more in vertebrates and those kind of animals, but not so much in the arthropods. You know, I'm sure there is quite a bit of variety there, because we are seeing in some of these vertebrates, and they are not all entirely unique. Many of these vertebrates have an ability to manipulate. You know, just like we can learn the sounds. So that is something we are seeing in birds also. The entire group of passerines, that's about 5,000 species. They have to learn their calls. This is not inborn. For almost all of the species, it's an innate knowledge. But for a lot of these species, they have to learn. Many mammals, they have to learn. We learn, right? But we have a template in our brain. Babies don't learn the sounds that they hear around them. They don't learn so many. Probably nowadays they hear so many sounds through TV. But they don't learn. They are tuned. So there is some kind of template that we have in our brain where we are tuned to certain kind of sounds, and those are the ones we end up emulating. A lot of studies, as they've gone as deep as they're figuring out, where the evolutionarily isolated populations are tuned to their own. Like for example, a lot of these mongoloid, they are seen in, I think in China, there has been some study where they have seen the babies, their Chinese babies are more tuned to the sounds of Chinese language. So there is some amount of that kind of evolutionary process probably happening. So there is, hope that answers, gives you some idea. I'm not so sure about insects though. Oh, do plants create any sounds? Yeah, absolutely. Plants are amazing. They have used these contact microphones to listen to plants, and plants are making sounds all the time. They're doing it. A lot of these are cellular level, but whether they are communicating or not is something we don't know. We know plants are communicating. I think I hope some of you have read that wonderful book by this German guy, Wohlreben. Yeah. That's basically where it talks about the communication happening between plants, where plants are communicating a lot of information. Of course, it doesn't happen as quickly as ours do, but it's a wonderful book. You should read. It's a great read, and it's mind-blowing. We can't even think about those things, but it is happening. But as far as acoustic communication is concerned, it's not. This is just at very infant stage of exploring. As I said, this whole part of exploring in these other invertebrates and plants is very, very early stage. We don't even know what it means and how they are responding, but I think still some way to go there. I'm sure a lot of information will come out over coming decades or so. So it should be interesting field to watch. Okay, I think we are done here. No. Are there any global databases available for such recorded sound? Absolutely. Birds, there is a couple of good places. eBird is allowing now, over last few years, they're allowing you to upload your sound recording. So many of us have done that. I have been in process. I think I still have a huge number of sounds I haven't uploaded. Xenocanto has been doing for a while. That is xeno-canto.org. That has a lot of bird sounds. This is a European funded organization. So that's a great repository. We will see where there is a big repository of bird sounds. As far as other animals are concerned, there are some for whales, but those are very research specific. They have created their own thing, but not a big repository still. iNaturalist, I heard, was planning to allow you to upload sounds of all kind of animals, but I think it is still in pilot. It hasn't yet been rolled out as far as I know. Last year it was still in pilot, and I haven't seen that still rolled out to everybody. But that should be one area, I think, where, if it builds up, it will be a wonderful way to have all these sounds in one place. Okay, all right. Is natural calamity prediction possible using sounds? I think it will be interesting one to study. As far as I know, I don't think there is anything right now but we are realizing today that there are sounds which are created, especially infrasounds, over hundreds and hundreds of kilometers away from us can be heard. I think there is one thing I want to explain here. See, there is something there when it comes to especially when it comes to storms or hurricanes, where animals have a sense a lot better than us. And my gut feeling is that partly it has got to do with these infrasonic sounds that these animals generate. A few years ago, I was tracking, there has been some of these cuckoos that were banded with a satellite transmitter. They're fitted with satellite transmitter up in China. And these cuckoos used to migrate down the Chinese region, get into India through our northeast, and cut across the Indian peninsula and go all the way to southern part of Africa. That is how far they migrate every year. And we came to know because of the satellite. And what I was seeing was there was a storm in the Arabian Sea at that time. And I was looking at one of these cuckoos, which was in area around Hyderabad in Telangana. So it was moving around in Telangana at that time, and I could see it was spending days. It hadn't moved, and many other cuckoos before it had jumped over. But the thing is, as soon as that storm dissipated, this bird took off from Hyderabad, and the next day I saw a couple of days later, it had taken off and it had gone non-stop and crossed the Arabian Ocean and got into Africa. And it was just amazing, mind-blowing. And I was like wondering, how did this bird know that there was a storm hundreds or probably thousands kilometers away in the Indian Ocean? How did it know that in Telangana? And I'm thinking possibly some of the ways is, there are these infrasonic sound waves that are playing some roles, but we don't know if these birds are able to hear them. Some birds are, but they have amazing ability that we can that we know even now. So I'm sure if we probably use that someday, we'll get a lot more information. All right, I think that's all. Great. Those are all the questions, right?
Yes, sir. Thank you so much for this amazing talk. It's a brilliant insight into a completely new field for most of us.
Great. Thank you so much. Thanks, Aditya.
Yes, sir. Thank you so much.
Thank you, Balram. Thank you all for listening.
Yes, sir. Thank you for your time, and we hope to have you again sometime for another maybe. Like
Absolutely.
call.
We'll probably do one in person sometime, so I can play some of these sounds, and that I'll tell you that is far better than any talk that I can give you.
Yes, sir. Understood.
Yes, sir. Definitely.
Okay, thanks guys. Take care. Bye bye.
Okay, bye, sir. Thank you.
Bye, sir. Thank you.